Hello, my name is Daniel, and today we will be going through the AMC 12B from the year 2012, so let's get started. First problem, each third grade classroom at Pearl Creek Elementary has 18 students and 2 pet rabbits. How many more students than rabbits are there in all 4 of the third grade classrooms? Okay, so in every classroom there are 16 more than rabbits, 16 more students, so this times 4 equals 64. That's the answer, it's C. Number 2, a circle of radius 5 is inscribed in a rectangle as shown. So this is radius 5. That means this much. The whole thing is 10. And the ratio of the length of the rectangle to its width is 2 to 1. So that means this is 2 to 1. But then since this is 10, that means this is 10. And so this is 20. And as far as the area, that's just 200 because it's 20 times 10. So that's the answer. It's E. Number 3, for a science project, Sammy observed a chipmunk and a squirrel stashing acorns in holes. The chipmunk hid 3 acorns in each of its holes. The squirrel hid 4 acorns in each of its holes. They each hid the same number of acorns, although the squirrel needed 4 fewer holes. How many acorns did the chipmunk hide? Okay, so let's say that the squirrel had X holes. The chipmunk needed X plus 4 holes. So the chipmunk had 3 acorns, so it's 3X plus 4 equals 4x, right? So that gives us 12 equals x. So that means the squirrel needed 12 for 4 acorns. So the number of acorns, that will be 12 times 4 equals 48. And that's the answer. It's D. Number 4, suppose that the euro is worth $1.3 if Diana has $500 and Etienne has 400 euros. By what percent is the value of Etienne's money greater than the value of Diana's money? Okay, so converting that to $2, that's 400 times 1.3 all over 500. So this is going to be 5.2 over 5 because we take out those two. And this is going to be equal to 104 over 100. And 104 is 4% more than 100, so it's going to be 4%. And that is our answer. It's B. Number 5, 2 integers have a sum of 26. When 2 more integers are added to the first 2, the sum is 41. Finally, when 2 more integers are added to the sum of the previous 4 integers, the sum is 57. What is the minimum number of even integers among the 6 integers? Okay, so let's say that the first 2 integers are a and b, right? And then they have a sum of 26. And then 2 more are added to the first 2, the sum is 41, so that we'll have c and d. And their sum will be 15 because they all have to sum to 41, right? It's at 41. And we have 2 more integers, e and f, and the sum will be 57. That will mean that these two they will have a sum of 16, and we want the minimum number of even integers. So for a and b, we can have odd and odd. That can make 26. C, D, that is even odd or odd even, so we need at least 1. Here we need 0, and here we can have this odd odd, so that also 0. And so if we add them all up, it's just 1. So the minimum is 1. It's A. Number 6, in order to estimate the value of x minus y, where x and y are real numbers with x is greater than y is greater than 0, shall Lee rounded x up by a small amount, rounded y down by the same amount, and then subtracted her rounded values. Which of the following statements is necessarily correct? Okay, so let's say that the amount it was rounded up was a. Then Shelly would have rounded x up to x plus a, and then y to y minus a. And if you subtract those two, that's going to give x minus y plus 2a. And this is going to be greater than x minus y. So the answer is A. Number 7, small lights are hung on a string 6 inches apart in the order red, red, green, 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 red, red, green, 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 and so on, continuing this pattern of 2 red lights followed by 3 green lights. How many feet separate the 3rd red light and the 21st red light? And 1 foot is equal to 12 inches. This is the pattern, right? So let's say that's one cycle. One cycle, that's going to be 6 times 5 lights. So it's 6 times 5, which is 30 inches. Converting that to feet, this is just equal to 2.5 feet. And from the 3rd red light to the 21st red light, if you see, they are all going to be the first red light in the cycle. So what we just need to do is just subtract these two, right? So that will be 21 minus 3 divided by 2. That's going to be 18 over 2, which is 9. So they are 9 cycles apart. So this will give us 9 times 2.5. So since it's 9 cycles times 2.5 feet for each cycle, this is going to be equal to 22.5. And that is our answer. It's E. Number 8, a dessert chef prepares the dessert for every day of a week, starting with Sunday. The dessert each day is either cake, pie, ice cream, or pudding. The same dessert may not be served 2 days in a row. There must be cake on Friday because of a birthday. How many different dessert menus for the week are possible? Okay, so if we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and there must be cake on Friday, and we have 4 choices in total, but then going right, we have three choices only. It's either pie, ice cream, or pudding. So that's 3. And by the same reasoning, that one has 3 choices. Since Wednesday, that just has to be not this one. That's just also 3 choices. And by the same way, all 3 choices. So this will give us 3 to the 6th power of choices, which is 9 cubed. That's equal to 729. So 729 is the number. It's A. Number 9, it takes Clee 60 seconds to walk down an escalator when it is not moving, and 24 seconds when it is moving. How many seconds would it take Clee to ride the escalator down when she is not walking? The fact that we have to zoom in on here is that the distance of going down the escalator is equal. So we can see that walking down when it's not moving, that's just, let's say that Clee's walking speed, c meters per second, and the escalator speed, let's say that the speed of the escalator is s meters per second. And so for Clee to walk, that's just c times 60, because it's 60 seconds. And that's equal to c plus s when she is riding the escalator. C plus s times, and then it's at 24 seconds. So it's 24. So that will give us c times 60 minus 24, which is 36, equals 24s. This gives us 3c equals 2s. Now, since what we want is the value of s, then we can just convert c as equal to 2 over 3s, and then put that in here, right? So that will give us 2 over 3s plus s times 24. This is going to be equal to 3 over 5s times 24. This is going to be s times 40, so it's 40 seconds, and that's our answer. It's B. Number 10, what is the area of the polygon whose vertices are the points of intersection of the curves x squared plus y squared equals 25, and this one? Okay, so first we know what this is. That's just a circle. With its midpoint, with its center in the origin, and it's a 5, minus 5, and plus 5 and minus 5. It has a radius of 5. And for this one, we need to notice that this is just equal to x minus 4 squared over 9 plus y squared equals 9. So this is going to be an ellipse that is centered at 4, 0, and is touching this right at 4, 3, and 4, minus 3. The drawing's a bit off, but that's correct. And it's going to be touching this side at negative 5, 0. So this is just going to be the triangle. So the area is just going to be this length, which is 5 to 4, which is 9, times, and then this length times half. So since this whole thing is 6, that means it's 6 times 1/2. This gives us 27. So 27 is our answer. It's B. Number 11, in the equation below, a and b are consecutive positive integers, and a, b, and a plus b represent number bases, and this is true. What is a plus b? Okay, so since a and b and a plus b, they are bases, then we can say that a squared plus 3a plus 2, that represents this, and then plus 4b plus 3, that's this one, that is equal to 6 times a plus b plus 9. So we can simplify this into a squared minus 3a minus 2b minus 4 equals 0. But then since a and b are consecutive positive integers, then let's say that b is the greater one. B is equal to a plus 1. Then if we put that in there, then this will give us that a squared minus 5a minus 6 equals 0. And that gives us that a equals 6, and therefore b equals 7. And here now we can just add those two together. That gives us 13, and that's our answer. It's C. Number 12, how many sequences of zeros and ones of length 20 have all the zeros consecutive, or all the ones consecutive, or both? Okay, so first we will want the cases that zeros are consecutive. That will give us 20 options when we have 1 0, and 19 options when we have 2 zeros, because we have 18 other parts, and we just see the 2 consecutive zeros as just one whole zero blob. So that's going to give us 19 possibilities, and then plus 18 possibilities for when there's 3 zeros, and all the way up to 2 when there's 19 zeros, and 1 when there's 20 zeros. So this is going to give us 20 times 21 all over 2, that is equal to 210. And for the ones that are consecutive, then that's just going to be the same thing and repeated. So that's going to be 210 also. We have to subtract both. Subtract the cases where zeros are consecutive and ones are consecutive. So both, this is going to be in either starting with zeros and then transitioning to all ones, or it's going to be starting with all ones and then transitioning to all zeros. So this is going to be 2 times 1 0 to 19 zeros. So that's going to be 2 times 19, and that's going to be 38. So what we now have to do is 210 plus 210 minus 38. So it's 210 times 2 minus 38, which is 420 minus 38, which is equal to 382. That is why E is the answer. Yeah, but that might imply that 0, 0, right? So all 0, this and 1, all 1, this is not possible. So in those cases, D might be the correct answer, and so the MAA has accepted both as the correct answer. Number 13, two parabolas have equations y equals x squared plus ax plus b and y equals x squared plus cx plus d, where a, b, c are integers, each chosen independently by rolling for a six-sided die. What is the probability that the parabolas will have at least 1 point in common? Okay, so for this and this intersection, to get that, we get a minus cx equals d minus b, because that's when this equals this. So now we get that x equals d minus b over a minus c, and this exists when either a is not c, because that way then the bottom part, then the denominator won't be 0, or d equals b and a equals c. This is just when they overlap completely. And so this should be 5 over 6, because a equal to c is just 1 over 6, and here this is 1 over 6, this is 1 over 6. This gives us 1 over 36. So it's this plus this, which is 30 over 36 plus 1 over 36. That's 31 over 36, and that's our answer. It's D. Problem number 14. Bernardo and Sylvia play the following game. An integer between 0 and 999 inclusive is selected and given to Bernardo. Whenever Bernardo receives a number, she doubles it and passes the result to Sylvia. Whenever Sylvia receives a number, she adds 50 to it and passes the result to Bernardo. The winner is the last person who produces a number less than 1000. Let n be the smallest initial number that results in a win for Bernardo. What is the sum of the digits of n? Okay, so we know that the initial number is n. If we have Bernardo and Sylvia, then if Bernardo gets n, then he would make it 2n, then Sylvia would make it 2n plus 50, then Bernardo would make it 4n plus 100, Sylvia would make it 4n plus 150, and then Bernardo would make it 8n plus 300, and Sylvia would make it 8n plus 350, and then Bernardo would make it 16a plus 700, and Sylvia would make it 16a plus 750, and next Bernardo would have to be 32a plus 1500, right? 1500, and this number, however small a may be, since it's an integer between 0 and 999, sorry, not a, it should be n, right, here and here and here, so it's 16n and 16n and 32n. So however small n may be, it cannot be negative. That's why this must be positive. But then we want Bernardo to win. That means for it to be the smallest number, that means this should be less than 1000, but this should be more than 1000, right? So what we want is 16n plus 700 has 1000 in between 16n plus 750. So this gives us that from this and this, we get that 16n is between 250 and 300. And so this gives us that n is between 250 over 16 and 300 over 16. So this gives us that n is between, this is equal to 15 and 5 over 8. This is equal to 18 and 3 over 4. And we want the smallest initial n. That means n must be 16. So 16 is n. The sum of the digits is 1 plus 6 equals 7. So 7 is our answer. It's A. Number 15. Jesse cuts a circular paper disc of radius 12 along two radii to form two sectors, the smaller having a central angle of 120 degrees. He makes two circular cones, using each sector to form the lateral surface of a cone. What is the ratio of the volume of the smaller cone to that of the larger cone? Okay, so if we have the circular paper disc here, like that, right, then that will be cut along two sectors, and the central angle is 120 degrees. That means we cut it in thirds, and like this. And so we would have two circular cones out of both sectors. So we can use this sector to form the cone, or we can use this part to make the cone. And so for each part we need this length, because that's going to be the circumference of the resulting cone. So let's try to go for the orange one first. This is going to give us a cone shaped like this, right? That's going to give us a cone like that. And this radius is going to be, yeah, that's going to be this much, right, that length. And so we can see that the circumference is 1 over 3 times 12 times 2 pi, because the radius is 12, it's 2 pi r times 1/3, because this is 120 degrees. and this is going to be equal to 8 pi. 8 pi is the radius of here, so that means the radius is going to be 4. So since we know that this length is 12, that means this length is also 12. So that means our height is going to be equal to, if we have 4 and 12, then we can use the Pythagorean theorem. So that gives us 4 times 2 root 2 equals 8 root 2. So the volume is going to be 1/3 times 4 squared pi, 16 pi, times 8 root 2. And then for the green one, for this one, we have to get this thing, the same, we have to get this, which is going to be the circumference of the cone, and the cone is going to look wider, like that. And here, same thing, we are going to do this much, so this is going to be equal to 2/3 times 12 times 2 pi, which is equal to 16 pi. This gives us that the radius is 8. And same thing, we have our triangle, and this is same 12, and this is 8, and so we want this, and we can get that by the Pythagorean theorem. And so if we do that, we get that the height is 4 root 5, and so the volume is going to be 1/3 times, and then the radius is 8, so 64 pi times h, so that's 4 root 5. And so the ratio of the volume of the smaller to the larger cone is going to be something like this over this. And so if we just cancel out the 1/3's, then we're going to have 16 pi times 8 root 2 over 64 pi times 4 root 5. And so these two can cancel, leaving 4, and 8 can cancel 4 and 4 root 5, leaving 2. So this is all 1 over root 10, which is equal to root 10 over 10. And that is our answer. It's C. Number 16, Amy, Beth, Joe listen to 4 different songs and discuss which ones they like. No song is liked by all 3. Furthermore, for each of the 3 pairs of the girls, there is at least 1 song liked by those girls but disliked by the third. In how many different ways is this possible? So let's see what these little women like. So we have 4 different songs, and at least 1 song that Amy and Beth like, Beth and Joe like, and Amy and Joe like. But then the 4th song, we don't know which one it is. And so this one, if it's different from these 3, then it could be that nobody likes them, or only Amy, or only Beth, or only Joe likes them, because no song is liked by all 3. This is if the last one is different, and it could also be the same. It could be the case that Amy and Beth like this one too, or Beth and Joe, or Amy and Joe like only this one too. And so in this case, then it's going to be just ordering 4, that's going to be 4 factorial, and then multiply it by 4. And so this is going to be 24 times 4, which is 96. And here we have 2 that are the same. So this is going to give us 4 choose 2, so choosing which 2 for this to be the same, and then multiply that by 3, because we need to know which one is going to be that, and then multiply that by 2. So this is going to give us 6 times 2 times 3, which is 36. And now we want to add all of those together. That's going to give us 132, right? So the answer is 132. It's B. Number 17. Square PQRS lies in the first quadrant. Points 3, 0, 5, 0, 7, 0, and 13, 0 lie on lines SP, RQ, PQ, and SR respectively. What is the sum of the coordinates of the center of the square PQRS? Okay, so if we get a grid here, like that, right, if we have a grid like that, and we can draw our coordinate lines, that will be the y-axis, and let's say this is the x-axis, and 3, 0, 5, 0, 7, 0, and 13, 0, that's going to be here, 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 and this is 7, 8, 9, 10, 11, 12, 13, so that's going to be 13. And then from here, we have like lines that make a square, and so we can see that the square will be made when we have lines like this, and like from here to here, like that, and lines from here that is going to go like that, that is going to go like that, and then this one that's going to go right like that, and so we can see a square that forms in the middle. And so now we know this coordinate because that's just integer coordinates, 4, 3. So we have 4, 3 already, and if we know this coordinate, right, then we can just get the midpoint of those coordinates, and then that will be the center of the square. And so to get that coordinate, we need this line and this line, and get their intersection. And so we will have y equals 3x minus 15, that's for this one, and y equals minus 1 over 3x plus 7 over 3, that's going to be this one. And so if these intersect, then we are going to get 9x minus 45 equals minus x plus 7. This is going to get 10x equals 52. That means x is equal to 5.2 and y is equal to, y is going to be equal to, if we put it in here, that's going to be 0.6. So we have x equals 5.2 and y equals 0.6. So that's going to be that point. 5.2 comma 0.6. And so we want to find the midpoint of these now. So the midpoint is going to be these two added divided by 2. That's going to be 4.6, comma, and then these two added divided by 2. That's going to be 1.8. And so this is going to give us, if we add these two, they're going to sum to 6.4. And so that is our answer. It's C. Number 18, let A1, A2, all the way to A10 be a list of the first 10 positive integers such that for each I between 2 and 10, either AI plus 1 or AI minus 1 or both appear somewhere before AI in the list. How many such lists are there? Okay, so yeah, since we have 10 positive integers and they either AI plus 1 or AI minus 1 or both should appear before AI in the list. First of all, let's consider the case where 1 is at the very front. So let's consider where 1 is at the very front. Then 2 would have no place to go but here, because this must come before that in the list. And same thing for 3, for 4, for 5, and 6, and 7, 8, 9, 10, all the way, right? So this has to be in increasing order. What if 2 is at the beginning? What if we have 2 at the beginning, and then we can have like these in any way? But then since we have 2 at the beginning, then these will all just follow. But then this one can go anywhere, because as long as it's inside there, then 2, which is 1 plus 1, that is always going to be in front of it. So 1 can go anywhere out of these 9. So this gives us that there's 9 choose 1 ways, right? And for this one, there was just only one way. That was just 9 choose 0. And next, if we have 3 at the first one, then we are going to have this much. That's just 4, 5, 6, all up until 10. And that's just going to stick in this order, right? But then 1 and 2, those can go anywhere inside here. But then note that 2 must come before 1, or else 1 cannot satisfy this condition. So this order must be in decreasing order. So this is just going to give us 9 choose 2, because if we only choose 2 spots, then 2 and 1 are going to fill that in decreasing order. And then same for 4, we have like 9 spots left. But then we now have this much that's going to be the same, and then we can only care about these 3. And they will also have to be in decreasing order, right? So it's going to have to be 3, and 2, and 1, something like that. And so this is 9 choose 3, because as long as we choose 3 spots for the 1, 2, 3 to go, they will automatically arrange themselves in decreasing order. And so this is going to keep going on until we choose 9, until we reach 9 choose 8, and 9 choose 9. And this will just mean that 10 has come at the front, and we have 9 to 1 that are going in these 9 slots, and they have to be in decreasing order, so they have to be in like 9, 8, 7, 6, all the way to 1, right? So that's what 9 choose 9 is. And now if you see, we just have to add all of these together, which is just 9 choose 1 plus 9 choose, which is just 9 choose 0 plus 9 choose 1 plus 9 choose 2, all the way to 9 choose 9. That's just 2 to the 9th power, that's 512. So that's the answer, it's B. Number 19, a unit cube has vertices P1, P2, P3, P4, P1 prime, P2 prime, P3 prime, and P4 prime. Vertices P2, P3, and P4 are adjacent to P1. And for I between 1 and 4, vertices Pi and Pi prime are opposite to each other. A regular octahedron has one vertex in each of the segments P1, P2, P1, P3, P1, P4, P1 prime, P2 prime, P1 prime, P3 prime, and P1 prime, P4 prime. What is the octahedron side length? Okay, so basically what we want is this length. And notice that if we say that this length is A, let's say this is, let's say this is length A, then this will also be length A. So this will also be length A, and therefore this will, that must be root 2A. That must be root 2A. And since it's a unit cube, this is just going to be 1. And so that means that this much, that's going to be 1 minus A. That's going to be 1 minus A. And now all that we have to do is draw a line from P3 to that vertex. That's going to give us 2 right triangles, which is this one and this one. And we can use the Pythagorean theorem on both, because we know what this length is, because this is an equilateral triangle, so this must also be root 2a. So this must also be root 2a, and we know the values for this and this. This is just same all the way, so that means this is also going to be 1 minus a, and this is going to be 1 since it's just a side of the cube. So we have 1 minus a here and 1 here. And so now we can get that this length that's in common. So for the green one, we'll just say it's going to be 1 squared plus 1 minus a squared. This is equal to this one, yeah, that triangle, which is root 2a squared minus 1 minus a squared. So this is going to become 1 plus a squared minus 2a plus 1 equals 2a squared minus a squared plus 2a minus 1. This is going to cancel like that, and we're going to get 3 equals 4a. This gives us a equals 3 over 4. We want the side length of the octahedron. That's going to be root 2a. So root 2a is 3 root 2 over 4, and that is our final answer. It's A. Problem number 20. A trapezoid has side length 3, 5, 7, and 11. The sums of all the possible areas of the trapezoid can be written in the form of this, where R1, R2, and R3 are rational numbers, and N1 and N2 are positive integers not divisible by the square of any prime. What is the greatest integer less than or equal to R1 plus R2 plus R3 plus N1 plus N2? Okay, so basically we have a trapezoid like that, and its side lengths are given, but we don't know which sides are which. And so what we have to do is we have to put a line that's parallel to that. So if we have this, then this and this, they will have the same length. So we need to get these 3 lengths from setting those side lengths, and then we need to see if the triangle inequality holds true, because that's the only way that those trapezoids are going to be possible, And so let's just check them. If A and B, they are parallel, so let's call those sides A and B, and A should be less than B. If A and B are parallel and A is less than B, then A and B, those can be out of 3, 5, 7, and 11. It can be 3 and 5, or 3 and 7, or 3 and 11, or 5 and 7, or 5 and 11, or 7 and 11. And so now let's test every one of them. If A is B and B is 5, that means this much is going to be B minus A, which is 2. And the other ones are going to be the ones that are not used. So this is 7 and this is 11, something like that, right? So 2, 7, and 11, those are going to be our 3 side lengths. This is side lengths of triangle. And so this is going to not possible because 11 is greater than 2 plus 7. And for 3 and 7, we're going to have 4, 5, and 11. And 4 plus 5 is 9, less than 11, so no. 3 and 11, that's going to be 5, 7, and 8, right? Because 8 is what we get for here. And so this is going to be possible, right? Because 8 is less than 5 plus 7. And now 5 and 7, that is going to be 2, 3, 11, right? And that's not going to be possible because 11 is greater than 5. And 5 and 11, that's going to be 3, 7, and 6. That's also going to be okay because 7 is less than 3 plus 6. And lastly, 7 and 11, we have 4, 3, and 5. This is going to be okay, right? Because 5 is less than 4 plus 3. And so we just have to get the areas for each of these. So for this one, we're going to get a trapezoid like that with it, and it's going to be 3 and 11, and we're going to have 5 and 7 like that. And let's say that if we have perpendiculars like this is going to be A, and this is going to be 8 minus A. So that's going to give us 25 minus A squared. Let's just erase this one. This is going to give us 25 minus A squared equals 49 minus 8 minus A squared, which is A squared plus 16A minus 64. So these two are going to cancel, and that's going to give us 16A equals 40. That gives us A equals 5 over 2, right? And since this 5 and it's 5 over 2, that gives us that it's a 30, 60, 90 triangle. So this must be 5 root 3 over 2. So that means height is 5 root 3 over 2, and the area, that's going to be 3 plus 11 divided by 2, that's 7, times the height. So that's 5 root 3 over 2. So the whole thing is 35 root 3 over 2. So we have that. And next, this one. This is going to be, that's going to look something like this. And it's going to be 3 and 5 and 7 and 11. And let's do the same thing that we've done. This is A, and this is going to be 6 minus A. So this is going to give us that it's 9 minus A squared equals 49 minus 6 minus A squared, which is A squared plus 12A minus 36. This is all going to cancel, and this gives us that 12A equals negative 4. So A is going to equal minus 1 over 3. And that might seem kind of weird because that must be a length. But then we can explain this by saying that the trapezoid is actually shaped like this. And so this length, that was minus 1 over 3. And so that means this whole thing is 11. And this one is, sorry, that means, yeah, this is 11, and this is minus 1 over 3. And so that's why it came out a negative value. So that's perfectly normal. And so we can get the height. That is going to be using the Pythagorean theorem. Root of 9 minus a squared, root 9 minus 1 over 9. That's going to be, that's going to be 4 root 5 over 3. And so the area, that's going to be this 5 plus 11 divided by 2 is 8. So if we multiply that to 4 root 5 over 3, that's going to be 32 root 5 over 3. So that's going to be one more area. And lastly, we have to consider this one. That's going to look like this. That's going to be 7, 11, 3, and 5. And same thing, let's say this is a. This gives us that 9 minus a squared equals, and this is going to be 4 minus a. So 9 minus a squared equals 25 minus a squared plus 8a minus 16. So these two cancel as always, and it gives us that 8a equals 0. So that basically means that this is actually the height, right? So this is the height. So 3 is the height. So this gives us that the area is 7 plus 11 divided by 2, so that's 9. 9 times, and then 3 is the height, so this is going to be 27. So we have this. And so these three added together is this. And so we have to add 35 over 2, 3, 32 over 3, 5, and 27. So that's going to be looking like 27. Yeah, so that's going to look like 27 plus 35 over 2 plus 3 plus 32 over 3 plus 5, and that's going to come out to something like 63 and 1 over 6, and the greatest integer less than or equal to that is going to be 63. So that's our answer, it's D. Number 21, square AXYZ is inscribed in equiangular hexagon ABCDEF with X on BC, Y on DE, and Z on EF. Suppose that AB equals 40 and EF equals 41 root 3 minus 1. What is the side length of the square? Okay, so what it gave us is that this one, that equals 40, and this one equals some weird value, 41 of root 3 minus 1. And so first thing we can notice is that XAB and ZEY, those are congruent. And we can see that because since it's equiangular, right, that means this and this, they are parallel. Also, this and this are parallel. And ZY and AX are parallel because it's a square. And so that gives us that it's similar because that means all its angles must be the same. But then since YZ and AX, they have the same length, that means that they are congruent. So that means EY is also 40. So EY is 40. And next we can draw some right triangles. Since all of these are 120 degrees and we have EF length, then we are going to focus on this side, right? And so if we draw 30, 60, 90 triangles there, we're going to get something like this right here. So that's going to be a triangle, and that's going to be another triangle over there. This is going to look something more like that, right? That's going to be a right angle, and that's going to be a right angle first. And since this is 120 degrees, that means this is going to be 60 degrees, and this is going to be 30 degrees. So that's a 30, 60, 90 triangle. That gives us that this length, that is 20. Also, let's say that AF, that has a length of like 2A, then this would be A, right? That would be A. And this much would be a root 3. Same thing over here, that would be 20 root 3. One more thing to note is that this triangle and this triangle, they are congruent. And that is because, first of all, they share this side. And this is 180 and this is 90 degrees. So that means this side and this side must be equal. And this side must be equal. So that means these two are congruent triangles. So that means this length is equal to this length. And this length is equal to that length. And so we can see that this is equal to a root 3, and this much is equal to 20 root 3. And we've got the length of EF right here, 41 times root 3 minus 1. And so we can compare this length in two different ways. So if we do that, we get 20 root 3 plus a root 3 equals 20 plus a plus EF, which is 41 times root 3 minus 1. So this gives us that 20 plus a times root 3 minus 1 equals 41 times root 3 minus 1. So if those two cancel, that gives us that a equals 21. And a equals 21, that gives us that the side length of the square. That is going to be, so we have this right triangle with a root 3 and 20 root 3. And so we can use the Pythagorean theorem now. And so what that gives us is the root of 21 root 3 squared plus 20 root 3 squared. That gives us root 841 root 3, which is 29 root 3. So that is our answer. It's A. Number 22, a bug travels from A to B along the segments in the hexagonal lattice pictured below. The segments marked with an arrow can be traveled only in the direction of the arrow, and the bug never travels the same segment more than once. How many different paths are there? Okay, so first of all, we want to, so we don't want to tackle everything at once. And so what we want to do is we want to split it into like different regions. So if we split it over here, and we split it over here, like that, then first of all, let's calculate how many goes from A to each of these. First of all, that's gonna give us from A, we can go here all upwards, or we can go one down and upwards like that. So that's 2, and we have 3, or we have 4, and we have 5 like that, right? So we have 5 ways, 5 paths right here. And if you see, it's gonna be the same for all of these 4, so it's all gonna be 5. And next, starting from here, let's see how many paths come to this point. So now let's look at this point next. Starting from this point, we have 1, 2, 3, and 4 possible. So that's all 4 possible. 4 plus, and then next, starting from here, that's just going to be the same thing. 1, 2, 3, and 4, right? So that's also going to be 4. And let's look at this one now. That's going to be also have the same 1, 2, 3, 4. But then we can use this one now, right? Because what if we go like that? Then this is used. And so we can choose which of these 2 to go, and then we can go through that one, and then we can choose which of those 2 to go through, so that's 4 in total. So that's 4 plus 4 more, which is 8. And the same thing is going to happen for this one. We're going to be able to go like all of these like that without using this one, or we can use this and go 4 ways like that, right? So that's also going to be 8 in total. That gives us 24, and it's going to be the same for everything. 24 and 24 and 24. And so lastly, we can calculate the possibilities of these coming to be. And so we can be coming like this, or like that, or like that, or like that, or we can use that and go like that, right? So that's all 5 ways. So this is 5 ways coming from here, and coming from here, 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 that's just all going to be the same. So that's going to be times 4, which is 20. And so at last we have 5 and 24 and 20 ways to multiply together. So that gives us 5 times 24 times 20. That equals 2,400. That's our answer. It's E. Problem number 23. Consider all polynomials of a complex variable pz equals this thing, where a, b, and c and d are integers. This holds true, and the polynomial has a 0, z0, with the magnitude of z0 being 1. What is the sum of all values p1 over all the polynomials with these properties? Okay, so first, basically, P1, that's just asking us to add up all A, B, C, and D, and 4, right? So that's what P1 means. And now let's just consider the parts when Z0's magnitude equals 1 and Z0 is a real number. If Z0 is a real number, then that's going to give us that Z0 that's going to be negative 1. So P of minus 1, this is going to be 0. That gives us that if we put that in here, that means 4 minus A plus B minus C plus D equals 0. So that gives us that 4 plus B plus D equals A plus C. But then from here, we see that C is less than or equal to B, and A is less than or equal to 4. So that means C and B, A and 4. This means that A plus C must be less than or equal to 4 plus B. So this thing is less than or equal to 4 plus B. That means D must be 0. So this means that D must be 0. This gives that D is 0. And for 4 plus B equals A plus C, because that's what's left now that D is 0. This gives us that A must be 4 and C must be equal to B, because this holds true. So A is 4 and C is B, so that gives us that if we just list the values of 4, A, B, C, and D, the 4 is just all going to be 4, and A must be 4, always. D is just going to be 0, so we'll just leave that blank. And B and C, they're always equal, but we don't know what they can be. So they can be everything from 0 to 4. So they can be 0, or 1, or 2, or 2, or 3, or 4, like that. And so now we can just sum all of these values, right? Sum all those up. Let's actually just write 0 for all z. D is going to be 0 for everything. And so the sum of these values, that's going to be 8, and then this is going to go as 10, 12, and then 14, and then 16. If we sum these up, this is going to be 60. So that's 1. that's when z0 is real. And now we have to consider when z0 is not real. When z0 is not real, then that's going to mean that the roots are complex, but then they are going to be in conjugate pairs. And that means if we factor this, then it's going to look something like z squared plus pz plus 1 times 4z squared plus qz, and then since the constant is d, then plus d. If we just now take away these things and just multiply them, this is just going to equal 4z to the 4th power plus 4p plus q, 4p plus q z cubed plus d plus pq plus 4 plus times z squared plus dp plus q z, and then plus d like that, right? And so we know that this is a, and this is b, and this is c. And so now if we care about those two, then a is going to be always greater than or equal to b. So what that gives us is that 4p plus q is always greater than or equal to d plus pq plus 4. And so if we put those over there, that's going to give us 4p plus q minus pq minus 4. This is going to be greater than or equal to d. This gives us that it's p minus 1 times 4 minus q, right? Because that's what this is factored as. This is greater than or equal to d. And also, if we look at these two, they look very similar. And so we know that this is a and this is c. And so we get that a minus c, this is going to be equal to, these q's are going to cancel. So the q's are going to cancel, and it's 4p minus dp. And that can be written as p times 4 minus d. And so now we can use this thing to predict our answers. And so first, we're going to think about when a is equal to c. First of all, we're going to think when a is equal to c. And that means this is going to be 0. That means this is also going to be 0, right? So if this is 0, either p is 0 or 4 minus d is 0. That gives us two possible ways. One is where, so it's either d equals 4 or p equals 0. So first, if p equals 0, right, no, let's say first if d equals 4. First if d equals 4, then that's going to give us, since this holds true, if d is 4, then these three must all be 4 also. That means a, b, c, and d, they are all going to be 4. Our P1, this is just going to be the sum of 4 a, b, c, d, which is just 4 times 5. Now that all of these are 4, this is going to be equal to 20, right? So that's another thing. And if p is 0, if p is equal to 0, then that's going to give us, since we know that d plus pq plus 4, right? So it's this one here, that is b. So this must be less than or equal to 4. So this must be less than or equal to 4, right? That means d plus pq must be less than or equal to 0, right? Since p is 0, that means d must be 0. So this gives us that d is 0. And since d is 0, we see that, so we know that q plus 4p plus q over there, this is always going to be greater than or equal to d plus pq plus 4, right? Q plus 4p, this is always going to be greater than or equal to no d now, and pq plus 4, pq plus 4. And so that means that q plus 4p, that must be 4. 4p is equal to 4, since p is 0, and that means that q is equal to 4. Because p is 0, so q is equal to 4, right? And so this is when d is 0, and q is equal to 4, like that. That's what we've got. But then if we put it inside here, then that's going to give us, it's just z squared plus 1 times 4z squared plus 4z, right? That is just the same thing as this thing, 44440, because if we expand this, then that's just going to give us this, right? So that's already covered. So this is already covered. I'll just write that down. This is already covered. So we don't need to repeat that again. So yeah, so we don't need to calculate that again. And then next, now since we looked at when a equals c, let's look at when a is not equal to c. Now when a is not equal to c, a is not c, then this gives us that, so that gives us that since this is not 0, then we can divide 4 minus d. So p is going to be equal to a minus c over 4 minus d. But then if you look here again, we see that here is a and c, and here is 4 and d, right? So obviously the distance between 4 and d is always bigger than that between a and c, right? So since a minus c is always smaller than or equal to 4 minus d, this gives us that p is less than or equal to 1. But then since a is not c, then p is not 0, so this gives us our lower bound of p, which is that p is greater than 0, right? So p is between 0 and 1, like that. And now we also split into cases where p is equal to 1 and p is not equal to 1. So p is between just 0 and 1, and it cannot be 1, like that, right? First, if p is equal to 1, then because of this thing, if p is equal to 1, then this is all 0. So that means d is just going to be 0, right? That means d is just going to be 0. Since same thing, d plus pq plus 4 is less than or equal to 4. That means d plus pq is less than or equal to 0. That means q is also going to be equal to 0. And so if we put those into here, right? If we put those into here, then that's going to give us, z squared plus z plus 1 times 4z squared. Our p1, this is going to be equal to 4 plus 4 plus 4, right? So that's just going to be 12. So we have another value. Now let's consider when p is between 0 and 1. But then if you do try this, then you will find that there is no such thing, right? So p cannot be between 0 and 1 because there will be a contradiction to q. Q must be greater than or equal to 4, but also must be less than 4, right? But if you try this, then you will find that there is no values for that, right? So that's impossible. And so we finally see that our full values are 60 and 20 and 12. So all we need to do is add those together. It's 60 plus 20 plus 12, which equals 92. And that's our answer. It's B. Number 24, define the function f1 on the positive integers by setting f1 of 1 equals 1 and n equals this thing is the prime factorization of n is greater than 1. Then f1 of n is going to be this whole thing. So what this basically means is that if we have like any integer n, like 400, this is going to be equal to 2 to the 4th power times 5 to the 2nd power. So this is basically what this means to the prime factorization. And then this is going to just add 1 to the base and subtract 1 from the exponent. So that just means that this is going to become 3 to the 3rd power times 4 to the 1st power. So that's just what this whole thing basically means. And now what we want is for every m is greater than or equal to 2, let this be true. For how many n's in the range 1 to 400 is the sequence f1n, f2n, all of that unbounded. So what unbounded means is that for every integer b, there is a member of the sequence greater than b, right? So that means that just means that there's no upper limit for f, right? For f of n, right? First of all, what we have to notice is that if n is a prime to the 1st power, right? So if it's a prime to the 1st power like that, and just that, then this is going to be bounded. Because right after this, it's just going to be 1, and then 1, and then 1 all over again, so it's just going to be bounded at 1. And so that means that the numbers that are unbounded, that must have prime factorization with all exponents greater than or equal to 2. So since that's, so if that is true, then since 400 is just 20 squared, that means all these prime factors, they are just going to consist of such numbers will contain primes from 2 to 19 only. Because this is just 20 squared, and so all it's going to contain are primes lower than 20, right? So the primes are from 2 to 19 only. And now let's try the powers of 2. For powers of 2, so first we're going to start with 2 to the 8th power, and then if we do an f of that, then this is going to become the base plus 1, so it's 3 to the a minus 1 power. And then next, this is going to be 4 to the a minus 2nd power, which is just equal to 2 to the 2a minus 4th power. Since we want this to always increase, this just means that there must be a, and so this just means that a must be less than 2a minus 4. So a is less than 2a minus 4. This means that a is greater than 4, and so thus a must be greater than or equal to 5. And so this basically means that this is unbounded for multiples of 2 to the 5th power, and just this is 12 numbers. So we have 12 numbers already, like that. If you look at this one, then you will see that in doing this, we go through a 3 to the a minus 1 power. And so this means that if a must be greater than or equal to 5, that means it's also unbounded. That means it's also unbounded for when a is 5, then a minus 1 is 4. So that's multiples of 3 to the 4th power. Because if a is 5, then this will be 3 to the 4th power. And so it's unbounded for 3 to the 4th power, right? And so those number of that between 1 and 400, that is going to be 4 numbers. So we have 4 more already. And that's already 16. And so we just have a few more left to go. And then if you check all the powers of primes, then you will only get 7 cubed only. This becomes 8 squared, which becomes 2 to the 6th power, which is just a multiple of 2 to the 5th power. And so that is okay, that is unbounded. So we have one more. And then lastly we have to consider product of primes. So these are going to be something like 2 to the 2nd power times 3 to the 5th power, like that. And since those must all be below 400, below or equal to 400, if you do this, you will find that only 400, which is just 2 to the 4th power times 5 to the 2nd power, this is possible. Just that's possible, and everything else, it's going to be bounded. And so we have 12 numbers, we have 4 numbers, and we have 2 more numbers. So that's going to give us 12 plus 4 plus 1 plus 1. This is 18 numbers. So 18 is our answer, it's D. Last problem, number 25. Let S equal x comma y, where x is inside 0 to 4, y is from 0 to 5, and x comma y is not at the origin. Let T be the set of all right triangles whose vertices are in S. For every right triangle, T equals triangle ABC with vertices A, B, and C in counterclockwise order with right angle of A. Let FT equal the tangent of angle CBA. What is this, right? But then this basically means the product of every tangent. So the product of every tangent of every right triangle that you can make in there. And so we basically have like this numbers. So this is what we have. This is the things that we have. This is x and this is y. So we should make right triangles like that. And then see their tangents, right? This one tangent is 1 because labeling ABC, that will be A and then B and then A and then B and then C. And we want the tangent of CBA, so we want this tangent. So we want the tangent of this angle, which is basically going to be AC over AB. But then it doesn't always have to be that way. It can be like this. And then it's going to be A, B, C, like that. We have to first not consider this one. Not considering the fact that x comma y cannot be at the origin. So not considering not origin. This probability, if we don't consider that, then this whole thing is just going to be 1. It's going to be 1 because we can flip the triangles to get the reverse tangents. And the flipping line, that will be this line, right? And so what I basically mean by this is if we just have any triangle like that, any right triangle, and if we flip that over this line, and that's going to be looking like this, then the tangent of CBA for this green triangle and the tangent for this orange triangle, they are going to cancel each other when they are multiplied. Because for the green one, it's going to be like x over y, and for the orange one, it's going to be y over x. So it's going to cancel each other. So that will basically make everything 1. And notice that if we have this blue line, then any triangle that we can make on the square, that is not going to be flipped onto itself. And so this is the perfect thing. And so this just gives all the answer of 1. But then now we must consider the fact that x comma y cannot be at the origin, right? And so we can't have triangles like that. And so now what we see is that 1, right? This one is going to be the tangents when the right triangle goes through 0, 0 times the tangents when it does not go through 0, 0. So what we want is this one. And so if we just get to this value, then we can just take the reciprocal of that, and we will have our answer. And so for the right triangle to go through 0, 0, we are going to need one more of this, like that. Yeah, then it must go through this point, right? And that means we can just try the same thing, right? Flipping triangles over a line to get their reverse tangents, but then we must make sure that the flipped triangle also goes through 0, 0. That way these will just be cancelled. And so that line, that perfect line, is this one right here, because, if we have a triangle like that, if we flip that around, then we will have this, and they are both connected to 0, 0, and their tangents are reversed. But then here, a slight problem arises. because what happens if there's a right triangle like this? Because if we try to flip that over, then it's going to go off the grid. And so what that just basically means that flipping this is not possible if it's touching one of these 5, right? And so if it's touching those 5, then it's not possible. And so those triangles are going to be like this, 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 or this, right? And so those tangents are going to be 1/5, or 2/5, 3/5, and 4/5. 1/5 is for the smallest thing, is for the smallest one, and 2/5 is for the next smallest, and all the way until 4/5, which is just this whole thing. If we multiply these products, that's going to be 24/625. But then this is not the end, but we have some more. We have some right triangles. So we have some right triangles that go through 0, 0, that go through 0, 0, and they touch the top line, and so they cannot be cancelled by that. And they don't have horizontal legs. If you see, then we are going to have only 2 cases of that. So if we have like this, so if we have something like that, and then our other legs are like this, then this is going to be a right triangle, but then this was not considered among these. So that's one. And one more is if we connect like this, and like this, and like that, right? So this is also going to be a right angle. So this is going to be a right triangle, but then this one is also not considered. And so if we just take the tangents of these green and blue triangles, then the tangents are going to be 3/2 and 4, right? And 4. And so if we just multiply these to this one, it's going to be 24/625, over 625, multiplied by 3/2 times 4. So they are going to multiply to 144/625. Now we can take the reciprocal of this one, and that will give us the thing that we want. So the reciprocal is 625/144. That is the answer. It's B. And so that was it for the AMC 12B from the year 2012, and thank you for watching.